So we will have a very basic thing. I have a two routers actually. So it is here R1 and R2. So it has some two ports. Just to have a familiarization, we have just like our A3 A4 nodes. It is a one router is how to connect with a port number 14, another how port number 30. So for my first task is that I have to connect between these router. So I am building a network. So when I am building a network, initially I have two routers. I have to connect between these two. So what all should be there in this? So these port all both these ports, because both these ports should be MPLS enabled, and these ports should be assigned with an IP address, and it mostly preferably we are connecting, as it is a telecom or ISP network, we are using point to point protocol only between two routers to connect. In at least in BSNL scenario, we are using a point to point protocol. So the router should be knowing what is the other port IP. The router 1 should know what is the router 2 ports IP, and similar. And these two will be in the same subnet. Means when I am telling hi to another router, another person, he should identify me. So such a way we will connect it actually. This is the basic connectivity we'll do. We'll have one router here and another router, and will be given an IP address in a /30 port, because we can have a usable IP of two IPs only in a /30 port. So we will connect between these two networks. So this is the basic connectivity. That in our case, it is we are connecting via optical fiber. This connectivity is purely optical fiber. So we are keeping one router in one exchange and another router in another exchange. So here I have shown what is actually a basic Ethernet packet actually. Have a purpose actually when we are, if we are planning to discuss about our E node B, E1 and all, we should be knowing what is an Ethernet packet. Actually in Ethernet packet there is a destination MAC address and there is a source MAC address. So I have a, in my router equipment or my router port, I will have a MAC address. Or actually if I am getting a data from a customer, then he have a MAC address of his equipment, that network interface card, or and the packet has to send to another destination, and that destination address also will be there. Usually it will be of a switch or something. The same way our router port will have one MAC, router 1 also will have one MAC, and router 2 port also have one MAC, and it have an IP. So by knowing these things, so router 1 will be learning router 2's MAC address through the protocol ARP. So it will resolve its address. It is just simply like we are telling hello, my name is so and so Dibu. So the person, he will also acknowledge me his name. The same way router will tell, hi, my port address is this one and I am sending to you. So the router 2 also will acknowledge, okay, so my name is this one R2 and my port address is this one. So whatever data is then forwarding to the fiber, the data will be prepared with some IP of that another node's port IP, and it have that MAC also. That is usually happening in the data link layer of OSI model. Actually, what is actually happening in the data link layer of OSI model? There is a lot more things are there, but these things may be better. Just we'll have an idea, because in a Ethernet packet, in the L2 domain, there will be a destination MAC address and one source MAC address will be there. This just keep in the mind. We will recall it when we are discussing about the E1 and other things. So it is a data link frame, then just skipping it. So here I thought to mention one more thing. When we are connecting to routers, actually R1 and R2, the very basic thing we have to take care of at the power level. Actually, in MAN network also, we are getting sometime errors. We are getting sometime packet drop. Sometimes tunnels are not switching. Uh, or frequent flapping is there. When your sites are connected, sites are getting S1 AP alarms. All this thing, and to the frankly, to around some 70 to 80% of such things are happening due to the power budgeting we are keeping. And sometimes we are not seeing the what is the value of the SFP, which kilometer, which distance my SFP is supporting. Actually, Tejas having one issue also. If you insert a SFP or replace an SFP, it will show the previous one until and unless we will delete the SFP manually. Then only will see the actual one. Always, when we are planning any network and we are connecting through a optical fiber or a patch cord, we should minimum we should keep the power budget. And the worst case scenario in the entire India means in everywhere now everybody is patching directly with the one interface to another interface and thinking the way, imagining that my SFP will take any power. Actually, that is a wrong thing, especially in the case of MAN network, because they are given different variety of SFP that will have a very stringent receiver sensitivity. Actually, we should take care that to the possible level, to the maximum possible level, and we, it should be at 100% sure power budget should be kept, and we should be knowing the SFP I am using 10 kilometer SFP at the trans, then my trans power will be around somewhere -3 or -4, and my power from the so we are having a node here and another node here. So we'll be connecting two fibers, dual fiber we are connecting from here to here. So here I am using an SFP of 10 kilometer. So say it is a 10G link. So trans power may be around some -3 dBm. Here accidentally I am using 80 kilometer SFP, or I did it checked also. For an 80 kilometer SFP, receive sensitivity is actually -7. So in some places we may have very good fiber, or our nodes are sitting in the same room in some reason. So what we will do, we will use a direct patch card and connect it to both devices. So here I will maybe have -3, and I will get at this end also -3 dBm. So actually my 80 kilometer SFP will recognize the packet correctly if it is less than -7. That means I need a power of -8 or -7.
Andi number TN14.
The link will be sometimes will be up, but there will be a error that will affect very much on the traffic, and even that SFP will have a very short span. So why I took this much time means it may be known to all, but what is happening in the present scenario, uh, sometimes these SFPs of fiber home that has a wide receiver sensitivity and a receiver sensitivity. So even though if you are patching directly with the direct patch cards, LC to LC patch card, it was not affecting much on system in other than very less cases. But Tejas was provided with a SFP range of 10 kilometer, 40 kilometer, 20 kilometer, then 80, even some SFPs with 160 kilometer also. So here receiver sensitivity and the power link budgeting should be very pakka, and otherwise there will be a definite chance of getting errors. and it is a vice versa in the lower side also. So sometime one side fiber will be very good, and another side fiber will be giving more loss. So that time also the same issue may be there. So always take the both side power budget as a very proper. This should be kept in mind. Actually, the most cases errors and packet loss or LC where whenever your LCO is telling there is a low speed issue, there is a 80% of chances are there your traffic is passing through such one of the link. It can be, may not be the immediate link, it may be somewhere else, and all the LCOs may not report at a time that you will have errors at a, or I am getting low speed. So we may have to check the tunnel path, how it is traffic is getting routed, then we have to clear it. There will, it is the easiest and it is easy to trace also in the Tejas network. It's not so difficult to trace out the such issues also. And there is a practice as it is a due to our field scenario, we have to use single fiber SFP in many cases. But what we are using now, or even BSNL itself is procuring with this our procurement policy is their the lowest quoting person. But what we are getting, actually, we are getting the old non-standard into SFPs. Actually, you can see third 1330, 1480 single fiber SFPs. These SFPs are not, even though it is written as 80 kilometer or 40 kilometer and all, these SFPs are never meant for the backbone transmission. It's never meant for actually transmission. That is actually never meant to keep it as a for the backbone link of two routers. Actually, these are actually just meant to connect LCOs to their our equipment. So because LCO may take the traffic of, even though you are maybe provided some 10G port to LCO, he may be taking some 3GB traffic only to the peak. So for him, distance will be very less. It may be 1 or 2 kilometers. And the thing designed for such things we are using in the backhaul. So with the 80 kilometer SFPs, they may be marked the range as somewhere around -20 or -20 for dBm as a sensitivity. But if it is working up to -24 and all, it will just giving definitely error, and it cannot take the traffic up to the level the how our normal dual fiber SFPs are taking. Okay. So even whatever I drawn also may not be visible, na?
Just 1 minute level. Till
Okay.
1 minute ago, yes.
So hopefully this having this I just added all the SFPs, all the dynamic range and all.
Are you showing any diagram now?
Now that PPT is showing, sir, not able to see.
It is not visible. Yeah,
So now it is
now it
okay.
is okay. It is okay.
So just I added the receiver sensitive part of this MAAN network where Tejas SFP is actually having. So it can be used or it may be there with almost all everybody. So then we will go with our system part actually. Yeah, so better thought to have some explanation of MBLS also. So what we learned actually, what earlier I told, there will be when we have some two routers. Just we think that we are actually newly installing one A3 and A3 nodes actually between two stations. Actually, this I taken from their Tanjavur B itself. That is something Vilamal and some other station. So, if actually when you are logging to our Tejas router, just normally if you are logging, to confirm always you can check what is the system info. So you will be getting the where the location and what will be the router ID and all. Actually router ID to the router we are giving to identifying one IP address we are giving as a router ID. Just like we are individual for each individual we are giving a name. The similar way we are giving a name for the router. So that thing with the simply we can see, and then we can see earlier I told there is a IP address we are giving to the each port. So that we can see with the command show IP interface brief. That is whatever interface with the IP assigned we will be getting. So it is actually in a A3 or A4 node. It's a A3 node. So both these ports are assigned with some IPs. And you can see they are using one VLAN also. So Tejas concept of connecting between two routers. They are not using the entire port to connect that. Means entire that port capacity to connect it. Capacity they are using, but they are using a individual VLAN to make a link or connectivity. So whatever traffic we are pushing from router 1 to router 2, say from here this router 1 to router 2, they are pushing via a VLAN something like 55 that VLAN. So even if required, I can use some other VLAN 100 and connect to some through, we can pass through and we can make it through to this router also. So that flexibility they kept and they are using also. And that we will discuss later. So in CPAN, whenever you people are configuring NNA link, you can always see we are using that port, entire port itself as a L3 port, and we are assigning IP to that L3 port itself, that port itself. Here what we are doing, we are assigning IP to that port, plus it is again dividing with the VLAN. So take it as a port for the simplicity purpose. So you will be seeing where it is there and what is the ARP. They earlier I told na, it is actually it is for knowing the destination address. ARP will resolve the MAC address of the other hardware address, other port. That here you can see. So my equipment IP is somewhere like 46.137. Here you can, in system info, you can see the equipment IP is actually 10.126 46.137, and it have two interface connected, that is 13 and 14, and it is allotted with some IP 10.131 47.26, and it was connected with an VLAN also 55. So here in that VLAN 55 interface, it is connecting to an IP 10.131 47.25. So from here you will getting the details that from which port to which port it is connecting, or which IP to which IP it is connecting, and what is the hardware address of that port. So this much details will be getting from this basic commands actually. So now we will just come to MPLS. So why we gone as a MPLS? Actually, anyway, I'm getting IP packet. So MPLS means with the IP MPLS data what I am receiving, I am wrapping it with another label. Why don't we forward the packet whatever I am receiving from customer directly to my network, and then I process and deliver to some other destination. So when we are processing the data. Actually, each packet I am receiving from the customer, I may be connected with some 4 or 5 or 100 of customers. From each customer, I am getting data packets. Just IP packet means with the data there will be some, where is the source IP and where to I send, that destination IP will be there. So each router has to check whether this IP is there in my routing table, or whether I am knowing this address, how I have to send. So in each packet, this router has to do entire checking of his address book, where to send. If it is there, I will send. If it is not there, I will drop it. So in the each packet, whenever is entering the our network, we have to do this business. So it will be just like the processor have a infinite capacity actually. So just like when you are moving from Tanjavur to Chennai, you are sending some parcel. So sending the first parcel is taking, and postman is seeing after some 10 kilometers, he is seeing some 2 roads. So he is getting down at one place with his first parcel. He is asking the person where to go, and he will move with in one road. Again, after 10 kilometers, he will ask where to go. So this scenario, rather than that, in the initial stage itself, he will wrap all the letters to Chennai in a bag, and he will move through one router. And that router will see, or the location, he will ask, I want to go to Chennai. So entire packet within the bag or entire letter in the bag will be moved at a time. So similar analogy they are using at the. So whatever packets, IP packets we are getting, we are wrapping with something more actually, and we are sending, pushing to the network. So this is the actual scenario, and as a BSNL, we are implementing the portion from ingress router to egress router. This is the network we are actually implementing and implemented, or we are managing. The customer will send me the data. When I am getting a data at my ingress, I will add one label, or I will add one more packet to above that. And that packet I will mention, this has to go to another so and so place. And from there you will get a new location where to move. So this network only we are actually implementing, because it is actually much faster, and we don't want to see it as IP packet or anything. Whatever packet I got, I will wrap it with another cover. So I don't want to know what is there inside that. Actually, it may be IP, it may be OTM, ATM, or something else. So I'm not at all worried. Whatever thing I watch, I will wrap with another things, and I will send my own way up to my person at Chennai or somewhere. And he may be knowing the last person. So he will remove the cover, and he will, by seeing his name, he will deliver to him. So this work we are doing with our network. So usually it is somewhat try to make it a self-explanatory. I'm getting one router will get one packet. It will see, okay, it has some label or some name. So I will remove, I will add some new location, and I will send to this person. In time he will send to another, and this packet will reach to the destination. So this is the MPLS we are doing actually. So more than MPLS, earlier itself I told, in MPLS scenario, something like there is a restriction of routers, or because one transmission network means there will be huge number of entity. In Kerala itself, one BA have 180 number of routers in a BA. It may be our South Zone or entire our South Zone NAB routers may be very less than this 180. It is when you are setting up a MPLS network in the transmission medium, either we have to divide our MPLS network as a small network. Otherwise, again, I need a huge processing capacity on routers, because I have all the processor should know where other processor is there, where I have to route and all these things. So I have to make it as a small MPLS network. That is the first diagram you are seeing. That means at the end, just like in your one SDCA, you have to make one network, then you have to hand over to another person, in turn another network, in turn it has to go. So that means you, for a one circuit to come up from one end to another end, you may have to do some tree creation. You have to maintain some tree network, and there will be three design aspects and all. So naturally, it was simplified, or we are added something more to that, that is called seamless MPLS. Actually, this one is the what we are BSNL is implementing in our transmission network. It is not the simple MPLS technology. It is the MPLS technology which made as a small group. Then we made it as a seamless. But for the customer, he will get the end-to-end delivery. So what we will do, there is a something called, we will discuss in the later videos. There is a BGP. So BGP is doing our that what all three network or four network is that, or we are unifying that thing. It is doing by the BGP parts. That is called BGP label unicast. So that we will go within the further detailed discussion, I think. So up to here, I think, sir, shall we have some interaction, because I don't know how much they understood or what I conveyed is clear or not.
Murali, it's okay now, Murali.
Yes, sir. It's okay. It's okay.
If you want any clarification, you can ask.
So very basic things, but you can ask any.
Sir, in that interface list you are showing, no? Above that one, two interfaces, like management and services, LO1, LO2.
Oh, that is actually the simple thing actually. Hopefully I can. This one is my one of my router, my second router. This is my third router. Okay, I will have connectivity here. Another connectivity here. Will be connecting here. So, as I told earlier, this port will have one address. Say it is 1.1.1.1, and this interface also will have one 2.2.2.2. This will give, I will give as a 3.3. Similar way. So I am trying to log into this router, because these are the, this port have an IP, means this port will have an address. So I can log into this router using any of this address. I can log in use 3.3.3, and I can log in using 2.2.2. But when this interface is going down, see the interface is going down. I am trying to reach this port 3.3.3.3, or this router with this IP 3.3.3. As that interface is down, I will not be able to reach that router. But router is up. Only this link is down only. This link is went down, so this port is gone down. So automatically this IP also, interface also go down. But if I try to log in this the node with this IP 3.3.3, It will not be reachable, even though the node is okay. So what the forum or the developers is came with some virtual port that we will call by name loopback. So they are added a loopback. It is a virtual port that will be always on. So you are giving an address like a dot a dot a dot a for this router, and if any of its interfaces are up, let it be this up and this cut. You try to reach this router by entering the IP a dot a dot a dot a, it will be reachable. So say the scenario, another link is cut and this one is okay and this link is broken. That time also, when you try to reach the node with the a dot or that will be up only. So irrespective of interface IP, the node is given with a virtual port, that is a loopback port. They are given, so that will be always on only, always on, and it can be reachable through any of its interfaces. And so what we will do, to understand that this router is available, that address also we will advertise or we will give to, when they are giving my address, I will tell my name is Dibu, or you can, in my home I may be calling by some name, and but this is my official name, that is, so that address also you will advertise. So that is the loopback IP, and it is a virtual IP, it will be always on. So in our, anyway, as you asked, in our seamless MPLS network, for management, that is accessing the node and doing the whatever creation or any modification or these things, it will be used by one set of IP, that is management loopback IP, and services are using by another set of IPs. So all your services will end with that IP. So for a service, when you are creating some tunnels or you are creating some services, you have to use the service IP of the node. So there are two loopback address for each node. You can see 10.126.46.137, that is the management purpose. For anywhere you are accessing node from, okay, let it be from Bangalore zonal node, or you are locally accessing, you will be accessing with the IP 10.126.46.137. For the service related portion, or it is just a slice of the router, for service activity that we are keeping the service loopback IP, that is there here itself they are given the name MGMT management loopback IP and service loopback IP, that both are in the default VRF, and the digit, this third digit, they will usually they will take the just higher number, there will not be any VLAN ID and all. Hope it is clear. Hello?
Clear, sir. Clear.
So anything, what is any doubt or anything? It's a very basic things we should know to go forward actually.
Regarding that receiver sensitivity, what is the best range? We have shown only one value. What is the minimum and maximum value? Is there any?
Best range.
Like,
so usually in all this window you can see there will be always a -8 or -9 is the best range for many things, but for don't take it for the 100 GSFPs. Up to 10 GSFPs, always -9, it is the thing that will not make any, because everything will be covered in that. Neither it may be maximum overload, always it is a maximum is -9. So -9 can be kept for anything. But in field scenario, many times you will be knowing fiber will be, because BSNL recently not laid much fiber. So all are almost 15 to 20 years old only. So naturally, one fiber may be giving 5 or 10 dB loss, another will maybe giving 18 or 20 dB loss. So even sometimes we have to you even Tejas what they are recommending, when you are using 10 kilometer SFP at one end, another end also you should give 10 kilometer to have a less load on system. But we may have to use one end 10 kilometer, another end 80 kilometer, because our one side fiber will be having high loss. This is our scenario. Especially for 100 G SFPs, the power level actually what we are reading directly is actually is a combined power. Actually, the 100G means it's a QSFP. It's just like a DWDM technology, because we are sending 4 wavelength at a time, and each wavelength is carrying 25 Gbps of traffic. So together, that 4 wavelength giving us a 100G bandwidth. So that together 4 wavelength means, as you know, when you are dividing something, some optical power by 2, it will be 3 dB low. Again by 2, so 6 dB low. So whatever we are seeing, if it is actually seeing something like a 20 dB or 21 dB in 80 kilometer 100 GSFP, it will definitely give the error or link will go down. So even though they are shown it as a minus 28 sensitivity, they are shown it for a single channel, not for the combined power. That may be kept in mind, because otherwise this 100G, if we give it as per their list, if we are going, usually we will get the very much big error, or we will having the link will go down. So in short, for the 10 kilometer 100G SFP, receive should be somewhere around -1, or something should be plus value. The minimum should be -1. So they may be transmitting somewhere around 7 or 8 dB, or 7 dB usually will be there. So maximum you can have 8 dB loss only in the fiber when you are using the 10 kilometer 100 GSF. So that idea may be kept.
Sir.
Uh,
Sir, if suppose in port 1 if you are using a 10 kilometer SFP, and port 2 if you are using a 80 kilometer SFP, so how to calculate this receive sensitivity, sir?
It's similar, because for a 10 kilometer SFP, maximum trans value will be there somewhere around -1 or -2. But the receiving part of that port is actually, we are inserted with the 80 kilometer SFP, is it? So for the 80 kilometer SFP, usually if it is at 10, it will be holding up to somewhere around 23, -23 or something. So if I am getting up to -20 also, or -22 also, that path will be okay. But what will be the problem? My 80 kilometer SFP will have more trans power. It may be somewhere around +2 or something. And if you think that your reverse fiber is having very less loss only, when you reaching there, you may end as a high power at another end. So that fiber you may have to introduce one attenuator or something. Same way you can take it.
Oh. Okay, sir. Okay, sir. Thank you, sir.
So shall we continue remaining? It's only a small portion actually. Sir, shall we continue with that? OSPF, and somewhere we will end up with RSVP. Okay, sir. Hello.
Yeah, we can continue.
So in usually MPLS network, actually this network what we are shown. So MPLS network will not be directly routers with the MPLS. Actually, all these routers, just to ask you, many are aware actually. Some routers actually they will make, or each company will make some routers with the so and so processor, and that will support so and so protocol. They will tell it will support MPLS protocol, it will support OSPF, it will support RSVP, it will support LDP, and list of. So, and we are molding the routers the way we like, or not we actually, it is a vendor like actually. They just maybe procuring some processor, and they are, and OSPF and all are actually open algorithm. So based on the algorithm, they are implementing the way how it should work. So anyway, with the MPLS, to have the entire capability of that MPLS network or to achieve our requirement, there will be always a underlying protocol. So in our MAN network scenario, we are using it as a OSPF. So OSPF means it is a very means complicated if you go in depth, but we don't want to actually that much information to manage our network. We want actually, it is OSPF means it is actually taking the by name open shortest path first. So when I am getting a package, I will route the to my shortest path. That doesn't mean my next person. Here OSPF is taking its metric is the bandwidth. OSPF always prefer the packet will be sent to the who have the more bandwidth. Or just like if you have a road between two places, you have one 6-line highway and a single line highway. Actually, we will opt for the 6-line highway. Or the same way, the router will opt for the most best path. So there is a OSPF usually will call the metric. It's OSPF cost. So why this should have a underlying network that will get into the idea. Actually, in this one you can see one is a non-MPLS router, means that is a customer router is giving me a data, and I have a ingress router, means it is the immediate router to which I am getting the traffic, or I am receiving the traffic as a as an ISP. I am receiving the data to the first ingress router. But my ingress router should know how to reach my egress router, or to which location I have to go, and in how many way I have to go, or I can go, in how many way I can go to other place. Or if the direct path is break, or direct path got some fiber connectivity broken, then how I should go. If that path also gone, how to reach. So for that, this OSPF is nowhere related to customer data. OSPF is nothing doing with the customer data. OSPF is handling its router reachability data. In the simple sense, in our network, we may have 40 or 50 routers. That OSPF, what it is doing, OSPF will find out all these 50 routers, in what distance all these people are there, and how I can reach them. In if first path is broken, how I can reach them in the other path, how I should do, or automatically how I have to adjust my path. All these things are handling by the OSPF. So that is the importance of OSPF. Actually, it is the underlying protocol we are running with our MPLS in BSNL network. In BSNL network, in MAN network, not in the BSNL network. Actually, in BSNL core network, till some 2-3 years back, they were using OSPF as the underlying network. They now changed it as a ISIS as their underlying network. Anyway, we are worried about the OSPF time being. So this diagram actually, hopefully I can show. So OSPF have some standard conditions also. In an area, they are restricting. If your router having a better processor also, you can keep maximum 60 routers, because these routers are learning each other dynamically. So we are not telling the first router that there is a router, OSPF router, and his name is so and so, and we are not telling to anybody. You are connecting to the network. Automatically, the first person is learning that somebody is added in my network, and his name is so and so, and I have to reach by him via this path, and I have to reach via router one via I have the post. I will have a highway to reach his house, and if that highway is closed, I have some two-line road via this path. If that also closed, I will have another path via a smallest one line road. So these details will be learning via dynamically, this automatically. It will learn automatically. So what will be the problem? When you are trying to learn everything automatically, your processor has to be do all the function for learning this only, because in a transmission scenario, whenever a fiber cut comes, all the router has to immediately rearrange their route, means the way how to reach there each one. So they, as a standard, industry standard, they were asking to keep limiting it to less than 50 to 60 routers in a OSPF area. In a single area, you may keep maximum 50 to 60. But as we are a telecom network, we may have to add routers in future also. So what we are doing, we are keeping 30 or 25 to 30 or 30 to 40 maximum in an OSPF area. And to the processor we have with the Tejas equipments, it is better to keep 20 to 30 routers in an OSPF area. So hopefully I will show some diagram. So here, just like we are defining some OSPF area. So what we are doing, is it visible actually?
Visible. Area number.
Some area number actually. So here some two routers are there. These two routers actually are C nodes actually. These are actually higher capacity nodes. There are chain of A3, A4, B3 nodes. It is terminating between this Z node and another one. Here we have there is a chain of nodes, and all these nodes actually allotted with the one OSPF area. Here actually it is area 740. So these routers will, what they will do? They will have actually connectivity. These area 14 routers will be knowing each other. They will be knowing each other. But none of the area 14 router will be know about the area 15 router. So he don't want to keep the details about this other area routers. So what we'll do, any changes has to happen inside a small area. That area nodes only has to rearrange or realign it. The other OSPF area routers will keep like that only. They need not worry about what happened to other area. They will be like that. They will be keeping the path and their reachability like that only. So what we will do, we will make it as a some 30 or 40 routers to one small area, and we will divide our network as a some group of OSPF areas. And as usual, you can see this router actually. This is the router. This router actually having two or more area is terminating in that. That router is actually sharing with the area 1 or something. So 100 G links are with that area, or so that router knows what is happening in the area 1 or in other area. And same router knows that I have one more area of routers or one more set of routers. There also something is happening. That node we are usually calling it as a ABR, area border router. So just be familiar with that name. So this was also another BS. It is, I was not got your Tanjore BA OSPF diagram. So I took it actually from something from Kerala. So what we had, I think maybe very small. And here you can see some nodes are assigned with some different. Here you can see area 3. And that area 3 routers are terminated between these two routers. So in order to have a L3 service or L3 connectivity or to provide some connectivity, you should have end-to-end tunnel reachability. That is the, whenever you are going for when you are going for providing one service from one end to another, you should have a tunnel. That is a tunnel reachability, or you are making a virtual path. Earlier, what we are doing, if it is a IP routing, we have to check in each router this IP where to forward, and there again we are made it as a label, and through that label we are making a virtual fixed path, that is we called as a tunnel. That tunnel will take different path whenever cable failures are there, or whenever there is a better link is added, that tunnel will be automatically changed. For that, we are that automatic or traffic engineering, that will be what we will call as a traffic engineering. That will be done by two mechanism. One is OSPF having its traffic engineering mechanism, and we are using it for this one. OSPF, we are enabling traffic engineering also, and along with we have RSVP TE. So here you can see in your router, there is a, in each, whenever I think you people are loading the script of its A3 and A4 nodes when you are integrating in the network. So that time there will be a script where there is a something called IP OSPF host. Here you can see where the cursor, if you can see, here you can see IP OSPF host. So in C node and all these 100G links, you will not see that because it is a IP OSPF host is for 100G links. Tejas is keeping as a 1, and if you are not mentioning anything, by default it will be 1 only. So just think these things in future troubleshooting time you may require, because some places when they were doing the script and all, they are not given the OSPF cost or TE cost. That is traffic engineering cost also not there in the equipment that we will explain in the next lecture. So here there is a only thing that we are using a underlying protocol to know my routers or my neighbors each other and how to reach that. For that purpose, we are using OSPF as the underlying protocol. So one thing you may be now knowing what all should be. So first thing in with the, as a seamless MPLS, the word I think we may be getting familiar today. Along with to implement that network, we are using one is OSPF. So that purpose I think you may be now already understood. So to see what are the functions running in the as a OSPF router in our node, just like in A3A4 node. I think this same node only I taken. When you see the router as an OSPF router, automatically you can see the running configuration of OSPF. There is a router OSPF, means your router is defining as a OSPF router. And for that router, again you are giving a router ID. That is, this is OSPF router ID. It is same as your management router ID. 10, 126, 46, 137. It is a one and same of that of your management router ID. And you are defining it as a point-to-point link. And then you are giving some IP address, means your whatever the WAN IP address you are given to your interfaces that we are advertising. Means it is advertising means simply we are telling to other person that these all are my address or these IPs are connected to me. If anything is there, let you pass to this IP. So here you can say earlier some person were asking me what is LO1 MNGT and LO2. So that two IPs also here we will usually advertise because it should be learned actually. So here what they are doing, you can see all the interfaces with the area. OSPF always mentioning in which area that router or that interface is there, not the router. The router need not be entirely on in a single area. The router interfaces will be in an area. So we are defining that. You can see the IP address 10.126.46.137, that is management router ID. That is in the area 5, that is already defining, and I have the network. Means I am connected to that network 10.126.47.137. That is my service related IP I am using. That also in area 5 only. Then the interface. These are the IP I am giving to port 13 and port 40 with the OSPF area. So these things will be, we can discuss enable BFT. That because tunnel or path should be automatically taken, or it is a BFT means bidirectional forwarding detection. The data I am sending both path, if any cut is there, you have to take over other. That all are actually a protocol or a thing we are telling to the router. You have to enable this. So remaining, it is the VLAN. Earlier I told that interface is defined with the VLAN. So VLAN also we have to define under OSPF. So with these two commands, you will be knowing what is configured under OSPF. So ideally, these many things should be there. And here, show IP OSPF neighbor. The command will give you the data that hello. Okay, shall we? So this show IP OSPF neighbor will give your neighboring OSPF router ID actually. So you can easily find out to which routers I am connected. So your this VM2010 is connected to 10.126 46.3, maybe some C node or B4 node, I don't know. And another is 10.126 46.136. So it is another side, it is connected to this node via so and so VLAN. Here you can see the VLAN and you can see the IP address given to that VLAN. With these two, you can identify to which interface it is mapped. So this way you can see the things in your EMS also. So here I can tell these two routers are actually, whichever is shown in green are the ABR of area border router of this area 5. Actually these routers are belongs to area 5. And this chain is totally terminating in one router. And this also terminating in one router. Only these three router is, only two routers having, in fact, in reality, the effect of dual ABRs. Why we are always keeping dual ABRs? Means whenever one equipment is gone down due to any reason, maybe power supply or node got reboot or something else, so card gone faulty, that time the traffic should be taken over by another node to the destination. So here if you see through your connectivity and all, even though these nodes having the purpose of having the two ABRs, but ineffectively this actually for 7 nodes will have, literally it is working with a single ABR. All these things we can get from the EMS. I just can took from the EMS only. So this part is actually what we should know minimum about what we will call OSPF and how it function in the MBLS, means our seamless MBLS scenario or MBLS as an underlying protocol. So this, I think there will be some doubts or some clarifications if required. We will clarify and move forward.
If we can say about the area and the backbone area, higher areas, lower areas, that hierarchy thing that we will discuss later, right?
If it is required, we can discuss that also, because if that is easier to get the continuation, means we will discuss that. Okay, then we'll go for that subject maybe.
Sir, Rajesh from SG Transmission, sir. Sir, in our BA network diagram, we are having 6 areas totally. So, for some of the areas, we don't have, we are having only one area border gate, as you mentioned. So, how can we some rearrangement can be done, whether we can make as 2 area in future? Can we
can do, sir. We can do. Even though there is a bit work from Teja's part side, we can do, and we have to do better.
Yes, sir.
Actually, that is always better.
Some of the areas I'm finding that we are having only one area border gateway router is there. We have to rework and do that, sir.
That we have to rework, and we have to ask them to create the second node as well ABR. They may have maybe kept some IP reserved in that pool and all. So that may not become a big issue actually.
Okay.
It is always better to keep 2 ABR separately as a disjoint location itself, not in the same location. It should be as a disjoint location. And if it is fiber availability is there to that router, then we should use it. It is a good thing, sir, actually.
But sir, earlier we have formulated this and all this area, this and all this area, like that we have done, sir. Whether we can change those area bifurcation itself will change if we plan for the second ABR. Whether it is allowed or it can be done without any service disturbance and all.
Can be done without service disturbance because already one ABR is working.
Yes, sir. Yes, sir.
So it can be done without much service disturbance, even though some routers we may have to reconfigure as the area. That we are doing in Kerala. In some cases, we have to, because some fibers are actually, it may be A3, A4 node only there, even though that path is totally different that of backbone, means our 100G router. We are keeping that area, we are bringing that node also to the main area where 100Gs are connected. 100G links are there. So it can be done.
But with the support from TCS, is it right, sir?
It should be done from the Tejas side only.
Yes, sir.
We should not handle such things. We should not handle is better, even though we should know the technology and we should able to guide them, but we should not handle because there is a MAAN IP sheet they are maintaining, and that should not be duplicated at any cost. And if at all duplicating, and our service only will go down.
Yes.
There will nothing happens to Tejas.
Rajesh, sir, I think in subsequent sessions, so we may discuss this case in next week or
okay. Okay, sir. Okay, sir.
It should be possible. Only thing is we have to do at the earliest. That is the thing. Then Tejas team will normally support. They have some work, but we have to ask them at the earliest. That is the only thing. Normally, in our experience, they will support.
Actually, sir, we had given some redeployment request with them also. They are also taking more time, and their support is because for redeployment and all, they have to concentrate and give the network reformulated and revised network diagram and all. This is taking more time, I think, sir. The
only thing we have to properly fill and share the WAN sheet for them. And the interface and the which IP and all, and we have to explain them what the change they required. Usually, as their script they are generating auto with their programs, it may not take much time now. They are taking some. If they are convinced and they are some mail we have to give from us. Actually, we want these changes and all these things.
Okay, sir.
It will be they are doing actually. We can discuss that, sir. Actually, with the network diagram.
Okay, sir.
Just I pointed out because I seen some places as actually.
Yes, sir.
In the same node only it is coming. As it is a huge vast area.
Yes.
It is up to outdoor person only can tell it is where is any possibility is there or not. So, just I mentioned in that diagram that much only.
Okay, sir. Thank you, sir.
Okay. So one thing as sir is told, so there is a concept in the OSPF that it is a backbone area, or it is a OSPF area 0. So earlier, anyway, I told sometimes about NIB. Earlier, NIB was actually our internet core backbone was using OSPF. So there was actually something called OSPF area 0. This is called the main backbone area. So what I will do, we'll think that here are some routers. Some 6 routers are there for me. So all these routers are in area 0. Area 0. And usually why I told it should be something less than 30 or 40, something like that, because any changes in the one area should contain there only. It should not go further. So I have more routers. So I am connecting somewhere here. It is area 1. Here I am doing something like area 2. Here also think that there is a area 2. So when it is a area 0 concept is there or backbone area is there, so if any changes happen in area 1, the scenario, this area, so some changes is happening in the area 1. So that changes will be, as I told earlier, changes will be known to APR. As it is a area 0, area 0 have one property that it will send the summarized LSA, link state advertisement to other area 0 nodes, summarized. So if at all any change happens in area 1, here only that area 1 area only that change will happen, and the area 1 routers only will update the changes. Any change outside this, that only will be given to other routers. And here I have one service. See, this area 2 is comes under this one location. See, Delhi is comes under area 2, and as you mentioned, okay, Chennai comes under area 1. Earlier I told we can have a tunnel inside one area only, but in the scenario of this one, as the link state advertisement is happening, we may have the tunnel connectivity directly from this area to here. So what will be the only thing, the area 0 is actually loaded. Area 0 will have summarized, not the entire change, summarized changes or summarized route changes only will be, or link state changes only will be sent to other routers. But in our scenario, we are never using area 0. That backbone area we are not using in seamless MPLS, in BSNL. So we are using disjoint areas only. So in our scenario, we are never using area 0. This we are not using. Rather than we may define this area as a area 1 or area 2. So here as a first area, I am using area 1. So this is another area 3. Area, okay, this is area 2. So if at all any changes in area 2 happens here, some cut or something, the reachability and all will be known by up to this route only. So any tunnel or anything will be formed from here to here only, not directly from here to here. So tunnels or any traffic path will be from here to here, and then from here to here will be there. And for connecting these two tunnels, there will be something like BGP LU mechanism will be there. So for a customer, for even for us also, it will be like a direct tunnel from A end to B end. Even though virtually, even we are creating tunnels between, we are actually creating two tunnels, and it will be making as a single, and for the service purpose it is functioning as a single tunnel or a single end-to-end entity. There is something called BGP LU is working. BGP LU family is working for this purpose. So this one is the disjoint. We are using absolutely disjoint areas. We are not at all using backbone area in the MAN network. That should be aware also. And in the same phase and all, many times we came across this. There was some mistake also happened. So hope it is somewhat clear.
Okay, Devan. That is enough.
So next part is actually RSVP. So earlier I told there should be some tunnel. Tunnel means we are configuring a path, or we are making a path as a fixed path. If there is no cable fault in the network, means we are identifying one path as the shortest path or best path, it having the much bandwidth, and it is as per my conditions. So to make one path, actually we are using something called labels. We are changing the labels between the point to point. So labels means again it is a something called some 20 digit data. So we are adding to, there is a information piece we are getting actually, one data will be there. So in that data there will be some L3 header will be there and some L2 header will be there. Then data information is there to the network. So L2 header, as we know, something like a MAC address only, and L3 is the IP address. So when it is making it as this packet to as a label, we are wrapping with label. This data format will change as something like, there will be one L3 header, that is IP address patch, and there is one thing called MDLS label. Here will be MDLS label, and again your L2 patch, here the data. So this MDLS label part, or this, it will be having some 32 byte data. Out of that, 20 is reserved as a MDLS label. As this, it is sandwiched between L3 and L2. Usually it will call MBLS as a MBLS 2.5, layer 2.5 protocol, like that. So it is as heard many times whenever we are going across the MBLS, every time first sentence will be that MBLS will be the layer 2.5 technology. So it is that's why we are calling it as a MBLS. So this label distribution and how this tunnel has to create it has to be done by RSVP protocol. That is another protocol that is handling the tunnel, how one tunnel has to be managed, and that tunnel should be, what should be the label and all. In CPAN we are giving it as a manually. This RSVP work we are doing actually, and we are only finding out the next router by clicking on them and finding the path. So that part we are automating, and There manually we are selecting the 10G path and 1G path. Here that work also RSVP has to handle. If I have 10G or 100G path, I have to prefer the 100G path. If I don't have, then only I should go for the 10G path. Okay, if I have one direct 10G path, I have but a 100G path with 2 hop. Then also I have to prefer the 100G path with 2 hop only rather than the 10G with 1 hop. So all these things has to be decided by, or these things to be automated by the function that is called the RSVP. So with the RSVP, there is something called traffic engineering. Traffic engineering, earlier I told, when there is a direct link of 10G and I have a 100G path with 2 or 3 hop, then also I will move via this 100G path only, until and unless I am preferring this 10G path above that. Then I can give some metric I can change in their definition. Then traffic will take, I will not opt for the 100G, it will opt for the 10G. So all these mechanisms will be handled by the RSVP. That is your label allotment and how it should be. So RSVP also, just like your OSPF, even its function is totally different, but it is there in all the routers. That is, you can see one headend will be there from where you are taking it as a source. Especially that headend you can always see when you are creating in the MAAN, you are selecting the source node. That source node is the headend, and that headend is always handling the tunnel total characteristics and how to handle and where all the things actually starting from the headend. Headend is actually processing the tunnel. So headend to its middle point. So middle point also again the same router you are defining as a RSVP router also. So that only shown here. You can see in your router there will be something called RSVP. Then there will be router ID. And here you can see signaling tunnel maximum 300. That means your MAAN router will have 300 tunnels. Maximum 300 tunnels will be passing through one router. That is the meaning of that. Then set RSVP enable and so on. So some basic commands are there. And here also we have enabled the BFD. So these things you will get from this command. And you can see the RSVP neighbor details also. So similar like to OSPF neighbor, the same neighbor will be usually to the 99% time it will be RSVP neighbor also same only to that OSPF neighbor. So here also you will get that remote router ID, you will get a remote IP address, you will get a. So all these things you have to check. If at all there is tunnel is not coming up in your network, then you have to check all these things. So I think that we will discuss in detail later. So you can see the RSVP interfaces. Is it available or not? Because same interface, same definition, everything will be there in the OSPF. Everything there will be in the RSVP, and almost somewhat similar definitions will be there in the BGP. So when you just simply go through, you may feel that everything is there in the node, but still it is not working. So, but you have to see the section wise. You have to see the router as a OSPF router. If everything is okay as a OSPF router, you have to see the router as a RSVP router. Then you have to see the RSVP router. Everything is configured well, and tunnels are getting up. So all these things you can see with these commands. So hope this is somewhat basic. It is okay for regarding RSVP. Can I get some feedback? Is it okay? So the another thing is actually what is called TE, traffic engineering link. So to have the traffic engineering mechanism, because if we have only OSPF metric, what will be the problem? Always OSPF metric will be 10G link will be with the cost of 10 and 100G link will be cost of 1 and all. So we need one more mechanism to the control which link I can prefer, which link I have to be there and all these things. So there is something called MBLS T link. So you can see the T link in your router. So I taken your two nodes actually, VLML and another one is my link. So these two routers, you can see that I just logged in. Both the router will have MBLS T link that will have the same local IP of your WAN IP. But earlier, the first step you are given, same IP you can give here. You can give it is there, and it should be there also. When any change is there, automatically tunnel will not come up. Especially you have to check the remote router ID. Is that interface is correct? You have to check the remote router ID, and you have to check the VLAN. You see this link is actually between these two nodes, link is working fine. So it is showing us like this. So whatever things we are summarized, we had discussed, just I took with the two node. I thought it is better to convey it. It's actually then router A and router B. It is a two physical nodes at Tanjore B itself. Whenever these two sides actually are related to what is the configuration in the both node actually. At the same time, you can see, you can compare what is the management router ID of that is actually VLML is actually 10 126 46 137. Here it is 110 126 46 136. Here you can see in that both itself it is written as a router ID. So with that command you can understand this router management loopback ID is actually this one, and another router management loopback ID is this one. And again you can understand it is the interface is actually given with the VLAN 55, that is port 13, and port 13 is assigned with one IP address. So this much information you will be getting from this a single command. So with this single command itself, you will getting the interface WAN IP, then that VLAN. The same way, when you see the router in the OSPF context, when you run the OSPF, the same way you will get the VLAN, you will get, and what is the WAN IP you will get, or OSPF advertised IP you will get. Similar to RSVP also. This both parties actually, left side part is of VLML and another is of another node, actually that nearest connected node only. This is the case of RSVP. So when you check the RSVP neighbor, you can see or RSVP, how many tunnels are there. When you are checking the RSVP neighbor, you can see how many number of tunnels are there, and in RSVP BFD is enabled or not. All these details you can see in a one single command. So T-link also given. So we planned up to this portion for the today. As BGP and other remaining part is a vast, and along with the BGP we can fully discuss about the seamless MBLS and the total working function actually. So better thought to stop here actually. So whatever is there we can discuss. Hope it is actually covered some basic part and it is bit informative list. So KK sir, remaining can be
Yes,
from your side.
anybody is having anybody needs any clarification, please ask. One more thing is, I will try to share the recorded session of this recorded session, and please go through this one or two times. And one more thing is, we will provide you some more recorded sessions. Recorded already, some sessions are with us, and one small YouTube video is also there. Uh, Before the next session, please go through this 2-3 times. Initially, you may not understand all the things at a time. You may have to go through it 2 or 3 times. After 2 or 3 times, I'm sure that you can understand it very easily, because the service concept we use is hierarchical MPLS or seamless MPLS. The first time we are implementing that architecture in BSNL, so we don't have any prior experience. This is the first time we are also implementing in NIB and such places. We have implemented only the flat MPLS only. So, as Deepu told, we cannot go for flat MPLS, because flat MPLS will have scalability limitations. So that is why we have gone through the hierarchical MPLS. This concept of this hierarchical MPLS or seamless MPLS, I will share you one YouTube video, just 20 minutes only. You please go through that video before the next session. Next week, after discussing with the DGM sir, we will have one more session. And if you have any doubts, please ask.
Sir, please once again, please clarify that any OSPF area 1 router can be communicated to ABR, and that this area 1 router may be connected, may be communicated to another area router through BGP, right? Yes, sir. May I
Yes,
right, sir?
yes.
Oh, okay,
We
sir.
are
Thank you.
making something like that. Actually, we are making it as we are making something, some more overlay actually, so that we will get the data from the remote router to any other router. So our ultimate aim is that we have to provide an end-to-end solution, irrespective of this OSPF area and all.
Okay.
Sir, basically, in flat MPLS, the flat MPLS means the MPLS we had implemented in our NIB network. There actually routes are exchanged from one area to the higher area through the OSPF level itself. Here actually, from one area within hierarchical MPLS, which we implemented in MAAN, here actually from one area to other area, OSPF level route distribution is not happening. Route distribution is happening via the BGP only. That thing we will surely discuss in the next session.
Okay, sir. Thank you. Thank you.
Thank you, Dibu. If Sri sir is there, please address.
Okay, any more doubts? Krishnakumar sir, let me give vote of thanks.
Yes, sir.
Okay, respected DGM Rajkumar sir, AGM Krishnakumar sir, Deepu Chandran who presented, and my fellow participants. I would like to extend my heartfelt vote of thanks for organizing this insightful training session on MAAN. The training has been a valuable